Now we start our series of examples on the chain rule. The chain rule, unlike the power, product, or quotient rule, really is used alongside each of those rules, as it's a method in and of itself, but it is really merged and married with all those other rules. And so, without any further ado, let's get started. My first problem says g of mu is equal to 5 tangent 3 mu squared. I don't know if you can notice the difference in this chain rule, in this problem, compared to the other ones. When we look right here at the angle, most of our other problems was always just x or y or whatever the case may be. Here we're allowed to get a little more complicated. And so as we do this problem, what we'll do, we'll say g prime of mu is equal to, we're going to use our coefficient idea, so we have our 5. The derivative of tangent is secant squared the angle 3 mu squared. The difference here, and this is where the chain rule comes into effect, is that you then have to take the derivative of your angle, and it gets linked with multiplication. So the derivative of 3 mu squared is 6 mu. Now once you have it listed like this, obviously there's some stuff that you can do to simplify this. I'm going to bring this 6 mu to the front, multiply it by the 5, and I'll get my 30 mu secant squared 3 mu squared. Again, the idea here is that you can link up your angle. You can go a little bit further with your derivative. And so you do your original 5 times derivative of tangent secant squared angle, and then you have to link the derivative of the angle because you never did the derivative of the angle. And so that gets linked. In all our previous examples, if you go back and look at any of those, when I have just a simple x here, the derivative of x is 1. That's why we never talked about it, because we were more concerned about the power, the product, and the quotient rules, learning those. Now we're going to just add to them with this thing called the chain rule.